welcome. In this video clip, I want to summarize some of what we've learned about Lewis dot structures by applying them to ionic compounds that have polyatomic ions. So what that means is we're going to be dealing with both ionic bonding and covalent bonding within the same substance. So let's start with the sulfate. Sulfate has 4 oxygens around it. And let's talk just about the SO4 2- ion. So I have 6 valence electrons plus 4 times 6, and then that extra 2 that came from the sodium ions. So that's 24, 32 electrons. Now, I'm going to go based upon what we would predict. Sulfate does an expanded octet that you would not necessarily predict. We're just going to stick with the basic predictions. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. And it needs a bracket and a charge. Okay? Now, within this compound, these bonds right here, those are covalent bonds from sharing electrons. But next to this, we would put 2 sodium ions. If it's a sodium ion, it had 1 valence electron. It lost that 1 valence electron. And so that's how you would depict the Lewis dot structure of this ionic compound. And it makes it very clear why we need 2 sodium ions. Whoops, and I've got a little bit of a blip there. That should be 2 negative, not 2 positive, so make sure you fix that. Okay, let's take a look at ammonium nitrate. I'm going to start with the nitrate. It's 3 oxygens. Nitrate has a negative charge, so I'm going to go ahead and put that in. So nitrogen has 5 electrons. I have 3 oxygens with 6. And then there's an extra electron from the charge. So that gives me 24 electrons to play with. So I'm going to make my bonds, satisfy my central. That's 8, 10, 12, 14, 16, 18, 20, 22, 24. Now, this oxygen is not satisfied, and so there's going to be a double bond there. Get my little messages out of the way, sorry about that. And this actually would display resonance. And we're going to talk about that more in another video. I'm going to leave it at just this structure for now to make the point I need to make, which is this. These are covalent bonds. But to the ammonium, I'm just going to kind of put dotted lines, I have an ionic bond. So let's put, oh my goodness. Let's see if I can clean that up a little bit. All right, try again. I'm going to put my ammonium with 4 hydrogens around it and a plus charge. So between these two, I have an ionic bond or an electrostatic attraction. So I've got 5, 6, 7, 8. Nitrogen brings 5, 4 hydrogens each bring 1, but this time I'm short an electron. It's been actually given to the nitrate. So I've got 8 electrons, 2, 4, 6, 8. Everything is satisfied. And that's how you would draw a Lewis dot structure for ionic compounds. Remember for ionics, IBC root beer, ionic bracket charges. Okay, and point out, we're dealing with both ionic bonds between a polyatomic and a cation or another anion, but covalent within your polyatomic ion. Hope you can wrap your mind around that. Thanks for joining me.